In this video, we'll be talking about aldehydes and ketones. The first question asks, which of these classes of carbonyl compounds can LiAlH4 and NABH4 produce successfully? So LiAlH4 and NABH4 are going to be hydride donors. When you compare the two, LiAlH4 is going to be stronger than NABH4. So if we look at our classes of carbonyl compounds, for NABH4, it will reduce acyl chlorides, aldehydes, and ketones. For LiAlH4, it will reduce everything. For the next question, we have to determine the major products for the reactions below. For the first reaction, this is going to be a Grignard. Remember, the products for a Grignard is going to be an alcohol. If we start with an acyl chloride and we have excess MgBr, we are going to get two successive reactions. That means we are going to form a tertiary alcohol with two of these groups for the product. For the next one, we have a ketone and we have a 1,2-diol. So this is going to be a protecting group reaction. This reaction is important because this protecting group protects this ketone from a reduction reaction, for example. Now, if we were to do the reverse reaction, we would get a different product. For the last reaction, we have a ketone reacting with a Y-lid. So this is going to be a Wittig reaction. For the Wittig reaction, the carbonyl oxygen and the phosphorus with the three phenyl groups will not be involved in the product, and this R group here will be attached to the carbonyl carbon. For the last question, it asks, what is the general reaction to form an imine and an enamine? So for an imine, we need an aldehyde or ketone with a primary amine with trace acid. For the enamine, We also need an aldehyde or ketone. However, we need a secondary amine with trace acid. So we will have a generic ketone with a primary amine. For the enamine, we will have the same ketone. However, we will have a secondary amine here. That concludes the video on aldehydes and ketones.